All right, so yesterday I gave you some problems to work on regarding force, just kind of basic, easy calculation. Keep in mind once we get rid of that, just click here. Really, we're working with two main equations for now. We have the one that Newton came up with, which is acceleration is equal to force over mass. Keep in mind, acceleration is in meters per second squared. Yeah, here, we'll do this. Bam, bam. There. Meters per second squared. That's kind of works. Force, we're going to measure in newtons for the most part, or kilogram meters per second squared. All right, and bear with me. Mass there is in kilograms. The other equation is just a rearrangement of this. If I want to get F force by itself, I would just multiply both sides times mass. So F equals ma. F equals ma. That's much better M. All right. So down there at the bottom, way down yonder, I have question number 1 written up there. A force of 20 newtons. All right. So right away, they're giving us force is 20 newtons acts upon a 5 kilogram block. So kilograms is a measure of mass. So mass is 5 kilograms. They wanted us to calculate the acceleration of the object. All right. This is pretty basic. Essentially, I can use either one with all the algebra we know. So let's just start with this one here. It's asking for acceleration, so I want to get that one by itself. Here it's by itself, so acceleration is equal to force, 20 newtons, divided by mass, which we said was 5 kilograms. All right, 20 over 5 should give us 4. All right, now for units, we know that acceleration is meters per second squared, but in this case, I have, let's use the other unit for force, kilogram meters per second squared is being divided by kilograms. Kilograms cancels kilograms. I'm left with meters per second squared. So 4 meters per second squared. All right, just because that unit analysis is still pretty important. All right, so one of the other things we're going to start working on are things called free body diagrams. Really, it's just, we just kind of indicate what forces are acting on an object. So we have a 5 kilogram block. 5 kilogram block. All right, we have a force of 20 Newton acting on it. That 20 Newton in this question could be from any direction at all. It could be, going downward, pushing up, pushing it from the side. I'm going to say that that is 20 newtons that way. The other thing I do is I could kind of indicate that it's being accelerated this way after I figure it out at 4 meters per second squared. All right, free body diagrams are something we're going to do for just about all problems that we have involving force, just so we can kind of see what are we actually looking at. All right, come down here, look at my lovely face there, bring up question number 2. Ooh, that's not quite going to fit, so let's go right there. All right. So in this case, number 2, an object of mass 300 kilograms. So we're just going to start with the free body diagram. 300 kilogram. All right. It's observed to accelerate at the rate of 4 meters per second squared. All right. So acceleration, I'm just setting my 300 kilogram mass as being accelerated this way at 4 meters per second squared. They're asking what force is acting in. All right. So one of the big things is this goes in. So Newton had 3 laws of motion. The first law of motion stated that the net. Now we're going with the second law of motion. For the net force of an object must be in the same direction as the acceleration. Okay. So with that, that way my acceleration's that direction. My newtons, my force has to be in that exact same direction. So now I'm just going to, they want to know force. They said mass is 300 kilograms. It's pretty big. Acceleration is 4 meters per second squared. All right, so out of the two force equations we're using, let's go ahead and use F equals ma. So in this case, we have 300 kilograms times 4 meters per second squared. All right, I'm not even going to get a calculator out for this. 4 times 3 is 12. Tag on 2 zeros at the end. Unit for force is newtons or kilograms meters per second squared. Either way is fine. So that's number 2. All right, number 3. All right. So the third question, the last one that I had you guys practice for today, is a 5 kilogram block is pulled across a table. So in this case, I'm being pulled, so my force, I'm just going to have it come from this direction by a horizontal force of 40 newtons with a frictional force of 8 newtons opposing the motion. All right, so in this case, I'm being pulled 40 newtons, but friction is pushing back because friction is always in the opposite direction of movement, okay? In this case, friction is just in the opposite direction as that pulling force. If the object wasn't moving, those two would be equal. But in this case, we're pulling with more than what friction is, so this thing will actually move. And in fact, they want to know what is the acceleration on this object. All right, so we have mass is 5 kilograms. We have the force we're applying, in this case, 40 newtons. One other way, maybe even a better way for me to depict this, is if this is a force I'm pulling with, friction would be in that direction. You know, either way, either one of these would be right. What I'm going to call that one, though, is I'm going to call that the force of friction, which isn't so important right now. 8 newtons, we want to know the acceleration. All right, first thing I have to do, I need to figure out what's my net force. So after I add all my forces together, what do I get? So in this case, I'm saying this way is positive, that way is negative. 40 newtons, that way, I'm going to have 8 newtons going in the other direction. So to find my net force, I'm really just going to take the force minus the force of friction. So in this case, 40 newtons minus 8 newtons equals 32 newtons. All right, so that's my net force. At this point, that's the force that's actually going to accelerate my 5 kilogram mass. So now I am looking for A, so let's use A equals F over M equals 32 newtons over 5 kilograms. That should equal, I'm going to guess 6.4. I can actually check that real quick. Old school. Yeah, 6.4. All right, so now that's 6.4 acceleration. We know acceleration in this case is measured in meters per second squared. All right, if that friction wasn't there, I would have done 40 divided by 5. If friction wasn't there, that box would have been accelerated at 8 meters per second squared. Friction, typically always there. Sometimes we want to consider it. Sometimes we're looking at ideal situations, stuff like that. All right, that's the first 3. Today we're going to try the rest. Good luck with them. There will be a key made for these. Also start drawing body diagrams for these, so the blocks with the arrows indicating the vectors of the forces, you know, the direction and the quantity. With that, good luck.